Um, Additionally, if you have questions during this presentation, you are more than welcome to use the chat feature. If you go to the, on my screen, I had to go to the More feature at the top in the menu and then hit chat, but you should see a little bubble for chat, and we will be responding to questions there. We'll have plenty of time for question and answers during this presentation. Additionally, if you are in need of translation services or closed captioning, that is available. If you go to the closed caption or the little caret right next to it. So with that, let's go ahead and get going into our meeting. The purpose of today's meeting is to review the draft technical standard for unreinforced masonry retrofits. And again, as I said, we'll be providing an opportunity for questions and answers. Some things we'll cover today include the background on URMs in Seattle. We'll also talk about why we have this technical standard. We'll talk about where it came from and where we're headed with it. And we'll spend most of our meeting reviewing what is in that draft technical standard, and then we'll allow at least a half an hour at the end for questions. So with that, let's do some introductions. I introduced myself briefly, but my name is Amanda Hertzfeld. I am the URM program manager with SDCI. I was hired on in November, and before that, I worked for FEMA, the Federal Emergency Management Agency, doing a lot of earthquake risk reduction activities. So let me toss it over to Kevin.
Hi, can you hear me, Amanda?
Yep.
Great. Yeah, my name is Kevin Solberg. I'm a structural plans engineer with the city of Seattle, and also with a background of doing seismic retrofits in the Seattle area from the consulting side of things. So I'll be discussing the kind of the nuts and bolts of the alternate method and the overall technical standard itself.
Thanks, Kevin. So before we get into the weeds on what the technical standard is, I wanted to do a little bit of talking on some background. Why are we doing this? So for starters, we have multiple sources for earthquake hazards here in the city of Seattle. Most people think of earthquakes and they think of either the Cascadia subduction zone, the big one, or they think of the Nisqually event back in 2001. And we have a lot of other sources that can cause earthquakes in the area. So there's a big fault zone rather under Seattle, the Seattle fault zone. There's fault line running up through Everett and Whidbey Island, the South Whidbey Island fault zone. So we live in a very beautiful and very tectonically active area, which is why we are so concerned about URMs, as we know about their vulnerability in an earthquake. So, looking at the probability of earthquakes, on the screen is a map of major earthquakes since 1880, and you can see there's been quite a number of them in the Puget Sound region. From a probability perspective, Seattle has an 86% chance of experiencing a magnitude 6.8 earthquake or larger in the next 50 years. And that's, Nisqually was a magnitude 6.8. So clearly it's not a matter of if there's an earthquake, it's a matter of when there will be an earthquake. And on the bottom there are just a number of memorable damaging earthquakes in the past 20-ish years. And you can see in most of these pictures, you can see bricks because we know that bricks do not perform well in an earthquake. So on your screen now is a picture from the Nisqually earthquake. This happened February 2001, and that was a magnitude 6.8, and it injured approximately 400 people and caused upwards of $2 billion in property damage. Over $8 million of that were repair costs to URMs in Seattle alone. So we know that history tells us URMs are vulnerable in an earthquake to both pedestrians and to occupants of these buildings. So we know how URMs fail. We know that parapets can break away and they can fall into the street, injuring pedestrians. We also know that walls can collapse, both endangering pedestrians and building occupants. So while we know how URMs fail, we also know how to improve the seismic safety of these buildings. And SDCI has been working on a technical standard that details an engineering approach to the retrofit of URMs. It defines the seismic hazard as well as requirements for wall anchorage, shear transfer, out of plane wall bracing, as well as parapet and appendage bracing. Kevin will be speaking to the details of these standards in just a few moments. And I first wanted to just point out, Seattle has approximately 1,100 unreinforced masonry buildings. A previous policy committee classified these buildings according to their occupancy type, the number of stories, proximity to areas for liquefaction, and landslide hazards. And that's what these classifications are. By retrofitting our URMs, we can increase the city's seismic resilience, we can reduce potential deaths, damages, and disruption to our economy and daily life post-earthquake. So going through a quick history, I don't expect you to be able to read all of these squares. I'm not sure how small they are on your screen. The point of this slide is to show that Seattle's been working on the URM issue for quite a long time. You see the first one was first squares in 1970. The city tried to adopt a URM standard and it was very quickly repealed due to cost and displacement issues. So if this were a simple problem, it would have been solved by now, but it's quite complex. And I just wanted to highlight on the slide additionally that in 2012, there was a team that developed a technical standard that was based largely on efforts used previously in California. And the technical standard that we're speaking to today is an updated version of this, and it's been updated to reflect building code changes, an increase in the understanding of our seismic hazard, as well as soil conditions. And the update of the standard was prompted by an ordinance passed, or sorry, by a resolution passed by City Council in 2021. That resolution, Resolution 32033, directs the city to develop a mandatory URM retrofit program that includes a definition of URMs, as well as the identification of the type of seismic retrofit standard required to bring URMs into compliance. That's what we're going to be focusing on today. This resolution also asks us to categorize a system for building types for prioritization of retrofits. It establishes a timeline for compliance. It asks us to develop an enforcement strategy, as well as a variety of potential funding opportunities and financial incentives. So we are working on these things in the background, but the first step is to really get this technical component established before we can start getting funding and everything together. So many of you might be familiar with the URM policy development working groups that I've got going. We have one on communications, on building owner and tenant needs, as well as on funding. If you're interested in joining those, feel free to send me an email. You should have that already, but if not, you'll get that at the end of this presentation. So while that ordinance does direct us to create that mandatory retrofit program, it has some specific goals that I wanted to cover. And that's that it wants us to focus on life safety by reducing the risk of injury from collapse of URMs in the event of an earthquake. So buildings retrofitted to this technical standard should still anticipate damages in an earthquake. There are more advanced engineering measures that can be taken to further improve performance of a building. And if you're a building owner, you can consult with a licensed structural engineer to explore these options. The intent of this technical standard, like I said, is to reduce the risk of collapse and injury from collapse in the event of an earthquake. The ordinance itself, once it goes live, We'll have a few other goals. One is to preserve Seattle's historic and culturally significant landmarks and structures, contributing to neighborhood character. So we're not trying to demolish buildings with this. We're just trying to improve life safety. We're also trying to improve the city's resilience to earthquake events by reducing downtime. And we want to minimize the impact of a retrofit program on vulnerable populations to the extent financially feasible. So with this, I'm going to pass it over to Kevin to walk through the technical standard.
Great. Thank you, Amanda. Again, I'm Kevin Solberg, and let's get started talking about what we've been up to in the past year. So the URM Technical Standard Task Group was formed back in July of 2022 to review the technical standard that had been developed about 10 years earlier, and to do some updates to it based on current codes and better understanding of the seismology of the area, and really just to improve the overall clarity of the document as well. Next slide, please. This is a list of the individuals who participated in that task group. On the left are internal staff at SDCI, and on the right are all the excellent volunteers that were involved. And we really appreciate all the effort from these individuals who contributed to development of the task or of the technical standard, several of which these individuals were also involved in the development of the 2012 standard as well. So from this list, there's a lot of experience represented here. A lot of engineers that have done numerous retrofits in the Seattle area and beyond who contributed. Let's talk big picture about what we expect in terms of performance from buildings retrofitted to this standard. So this is a plot or a figure showing different levels of damage that we might expect to a building in different types of earthquakes. So if we start on the left and look at the blue box, we have the Nisqually type earthquake events, which Amanda mentioned earlier. And then if we work our way down, we can see the type of building damage we might expect for new buildings, for buildings that meet some sort of basic retrofit standard, and then finally for older buildings such as these URMs that are unretrofitted. So think of these unretrofitted URM buildings in that bottom row currently, and we are trying to use the standard to get those buildings up into this second row that's highlighted with this red box. Similarly, as we move across with these columns, we have a Cascadia subduction zone event represented here. That's a magnitude 8 or 9 earthquake occurring out on the west coast of Washington State. And then finally, kind of the maximum considered earthquake that really impacts Seattle is a Seattle fault type event. And that's a very shallow, very strong shaking earthquake that would have a lot of impact to the building stock in Seattle. Next slide, please. So the technical standard is organized into a few different pathways for compliance. And this flow chart generally shows how one would go about navigating the technical standard. First, you start with there's the first section here is essentially some general requirements and some references back to the Seattle Building Code in terms of overall submittal requirements and what kind of drawing standards are expected. The second is definitions, which includes the definition of what a URM building is. So there's some specific language there about what this standard entails and what scope of building it includes. And those are URM bearing wall buildings. So essentially buildings without reinforcement in the walls. Section 3 then goes on to define some of the retrofit method options that are available. There are ways to essentially exempt your building from the requirements of this method, and we'll talk about what that is. And then there's 2 retrofit options of varying level of complexity and cost that a building may or may not qualify for, and we'll talk about what those qualification requirements are. So let's start with the exceptions. So there have been a lot of retrofits to buildings, you know, for many, many years in Seattle. There's a lot of fitted URM buildings that exist today. Seattle has what's called a substantial alteration requirement for buildings that go through substantial renovations. And a lot of those buildings will qualify to be exempt from the requirements of this method. So first off, we have a few categories represented here. We have substantial alterations that were built or retrofitted to the 2006 Seattle Building Code or newer. And buildings that meet that criteria really don't require much of any documentation. You essentially show us the permit number and what it was retrofitted to, and that's about it. Now, substantial alterations also could qualify if they were built under the 1994 Seattle Building Code up until the 2003 Building Code as well. In this case, they could be exempt, but they also need some backup documentation, essentially to show that the buildings were retrofitted as intended. So a structural engineer would be needed to review the drawings and make a statement such that indicating that they were the the design essentially met the code of the day. There'd be some field verification requirements of the retrofit itself, going out there and looking at the specific components to make sure they're there and that there's no significant deterioration of any of the building components, particularly the masonry. And then also that there's some key retrofit components present in the building. And we'll talk about what we think what those key retrofit components are. Finally, there's this, well, I should go back to that last slide. Finally, there's a third pathway that's a bit of a catch-all, but there's a lot of buildings that may not quite meet the specific substantial alteration requirements from the 94 UBC and beyond. But that still may be able to qualify, and we provide a pathway for doing so to be exempted from this approach. If it can be basically demonstrated that what was done to the building meets the overall performance intent in terms of life safety and prevention of collapse that we talked about previously. So let's move forward and talk about, now that we've covered what exceptions could potentially apply, let's go into the what would be required to qualify for the alternate method. So again, let's just talk big picture. The alternate method is kind of the simplified version where we're only targeting very specific components of the building versus the code-based retrofit, which is the more comprehensive retrofit of the building itself. So next slide, please. So qualification for the alternate method consists of several items that we would be looking for in the building, which are listed here. And the overall goal of this qualification is to basically ensure that the building is somewhat regular in its shape. Regular buildings tend to perform better in earthquakes, and that the lateral system of the building is such that there is some basic level of lateral resistance to the building that the building has. Next slide. So let's first off talk about one of the requirements would be in order to qualify for the alternate method, the amount of wall in a building would have to be such that it covers at least 40% of the overall length. So shown here in this figure, the orange indicates the overall, this is just an example, but the overall length of a building. And you can see those blue arrows there representing the individual piers. You can also see the blue arrows up above on the second floor. So those individual blue arrows, the length of those piers added up has to be at least 40% of the overall length of the building. Now you can see there's a few locations where we don't show blue arrows. Those are locations that we, just by looking at the photograph here, it doesn't look like those individual wall panels meet this 2-to-1 ratio requirement. So the height of the wall compared to the width of the wall cannot exceed 2-to-1, which, for example, on the bottom right there next to that doorway, it looks like that pier might be beyond that limit. Next slide. Here's an example of a building that potentially would meet the 40% ratio, you can see here that all the walls stack quite well. The size of the walls relative to the size of the window openings is relatively small and probably meets that 40% requirement. As well as looking at most of these piers, it looks like it meets that 2-to-1 requirement. So this just might be an example of a building qualifying for this alternate method. In addition to the 40% wall pier length, there's other requirements such as buildings must be less than 6 stories or less to qualify for the method. They must not contain risk category 4 type functions. That's a term we use to categorize building depending on their risk. So that includes emergency shelters, fire stations, hospitals, buildings containing hazardous substances, things like that that have there's a strong public need for the use of that building after an earthquake wouldn't qualify for this alternate method. Again, because this is kind of the bare bones basic retrofit method available. In addition, the building would need to demonstrate that it has 2 lines of resistance from lateral forces in each direction. So you can see in this example here, this building has a nice solid brick wall running along its full length. So that certainly would qualify. However, that what we call an open storefront building, which is the large number of windows relative to the area of wall on the front of that building, may push it wouldn't necessarily meet the 40% pier ratio, but there is a pathway to also qualify by adding a specific brace on that side of the building to meet that 2-liner resistance requirement. So there's a pathway that way as well. In addition, there is some testing requirements needed to qualify. We want to make sure that the mortar that's between the bricks is strong enough to work based on kind of the overall assumptions of strength that we're using for qualifying. So in this case, this is an example of doing a masonry shear strength test of a specific brick to qualify for the method. In addition, the building needs to have wood diaphragms or wood floors. So wood floors are a typical for the buildings of this era of construction. And there's some specific limitations of what those floors are comprised of. So for example, there generally cannot be straight sheath diaphragms on these floors. So the picture indicated here shows some straight planks supporting the floor that typically wouldn't be allowed. However, there are some exceptions to that. So if the span of the span between walls of these floors is within a certain limit, you could potentially qualify that way as well. So those are the overall qualification criteria needed to use this alternate method. So what is the alternate method? Some of you may have heard the term of bolts plus. Bolts plus is a term commonly used in California to describe a lot of the unreinforced masonry retrofit work that has occurred in that state. The method that is developed here is quite similar to that. So let's go into the details of what it actually is. So let's start the basic assumption as we established kind of in the qualification criteria is the building has a very basic lateral system. So we feel like it has the ability to more or less stand up on its own, provided that we address some of the common deficiencies in these older unreinforced masonry buildings. So this method was developed overall to minimize the cost of the design and construction. So limit costs basically while also addressing the key life safety issues associated with these types of buildings. What's different from the version of this that was developed in 2012 is that we've now taken the specifics of this method and put it into this document itself. So the method is fully encapsulated within the document. And part of the reason we did that is we wanted it to be very clear exactly what work needed to be done, what calculations needed to be conducted in order to determine bolt spacing and aspect ratios, and all the things that we'll talk about associated with this method. There's four key components that this method addresses, and that's wall anchorage, diaphragm shear transfer, out of plane wall bracing, and then parapet bracing. And if you go to the next slide, we'll talk about each one of those. So again, going back to the slide Amanda had showed previously, this is the typical failure mechanism that we often see in unreinforced masonry buildings. You can see breaking away of the parapet on the left, and then you can see the floors giving way from the wall itself, which leads to overall collapse of the building. Now, how do we address that? Well, first off, with the parapets, we install parapet bracing. There's a few example photographs of that here. This generally sorry, I can go back real quick. So as you can see here, it generally consists of steel angles or some other means to support the parapet towards the top of it, and then tie that back into the floor in some way. Next slide. Now, the out-of-plane bracing is a requirement to ensure that tall, slender walls don't fail out of plane, which you can kind of see happening here towards the end of this animation. So what happens is if the support of the walls is too far away, such that you end up with a very slender wall, that could lead to out-of-plane failure. So we require that the walls meet certain height to thickness ratios. So if those ratios are met, then no further action is necessary. And a lot of the walls out there will meet that requirement, but there's a sampling out there as well that wouldn't. So I just want to show here a few photographs of walls that didn't meet that height to thickness ratio, and in which case engineers added bracing mid-height of the wall to address that. You can see that here on the left with the angles, and then on the right with this curved member next to this stained glass window. And then finally, we have the anchorage of the walls, or of the walls to the floors themselves. So this is probably the most critical piece of all this, and this ensures that the walls don't break away from the floors and lead to collapse of the building. And so this is addressed by either through bolted anchors, historically called rosettes, that tie the floor into the wall, or oftentimes what's often used now is angled rods that go into the wall and are essentially glued with epoxy in place. And so you can see a few examples of that here. One tying it back into a concrete floor, and on the right, top right there, tying it into a wood joist that is perpendicular to the wall. And then on the bottom right, another example of these floors being tied back into the diaphragm where the joists are parallel to the wall, in which case added blocking is typically necessary in order to develop those wall anchorage forces back into the floor itself. So those are the main components of what goes into the alternate method. It's these four components: the wall anchorage. I say four components. It's really kind of three components because two of them kind of work as one: the wall anchorage, and there's also a requirement for making sure the floors work in shear against as attached to the wall. But you can see the basic components here as it's addressed and what a system would look like. The animation on the left shows what the overall retrofit would result in terms of overall building performance. I would like to note that this alternate method is considered a very, very basic retrofit, which only addresses the absolutely most critical life safety components of the building. And as if there's building owners that are listening to this call, I want to make sure it's clear that using this alternate method does not relieve you from the typical requirements associated with a substantial alteration. A substantial alteration and the seismic requirements that go along with that are more rigorous than this method, and could be triggered if there's other rehabilitation work done to the building in the future. So I'll make sure that's clear. And I think that's a good segue to our next topic, which is what happens if you don't qualify for um, the alternate method. So if you don't qualify, that puts you basically into what we're calling the code-based retrofit. So the code-based retrofit is essentially the seismic retrofit component of what would typically be required for substantial alteration. So again, I want to stress this is just the structural piece of that. And in addition to the essentially what we covered is associated with the alternate method, it takes that next step in that essentially if you've ended up here, there's concern that the overall lateral system of the building is not sufficient. So that's a big piece of what this method would typically address. Um, there are some breaks given in this case. For example, you don't have to use the seismic forces for that of a new building. You typically use around 75% of what those forces would be. So there's a break there. Um, and then there are options for using some retrofit standard documents that exist and are commonly used in the United States and around the world that provide these checklists, as you can see here on the right, highlighting big picture things that an engineer would go through and look for in the building and determine if that is compliant or non-compliant. So the example here, as you can see, for example, the redundancy check was compliant, but the shear stress check was not. And that would be something that we would probably commonly see as it wouldn't be passing these shear stress checks, which would then result in added lateral systems to the building. Other things could be strengthening of the floor, diaphragms. And let's go to the next slide and look at a few examples. So here's an example of a building that this building went through a substantial alteration. We'll just, because as associated with this method, we'll just focus on the structural components, which would be the only part required as part of this technical standard. The isometric on the left shows the structural components that were added to the building. We see some common things like the strong backing of URM walls for that out of plane support of those walls, but then we also see some concrete walls that were added in the corner of this building, along with some what we call drag struts that tie the diaphragm back and deliver those forces from the diaphragm to the walls. So essentially better connection between the floors and these new lateral elements in the building. So the center picture is an example of that under construction. These concrete shear walls being added, and the picture on the right is essentially what the finished product ended up looking like in this particular building. There's other examples. You'll see a lot of steel braced frames, particularly go walk around Pioneer Square. You'll see some applications of this, but what they are big steel braces that are installed in the building, oftentimes with new vertical columns as well. The picture on the left is a steel pipe brace. The picture on the right is a wide flange type brace, and then in the center, and then on the right is a proprietary system called a buckling restraint brace, which is something that's more commonly seen in these types of retrofits. So that's essentially the technical standard. We went over essentially the different retrofit methods that would apply here, what exceptions could potentially get you out of requiring further retrofit work. We talked about what qualification or what would qualify in terms of building attributes to use the alternate method. And then we talked a little bit about if you didn't qualify, what would be part of the overall retrofit using a code-based approach. So with that, I'll pass it back to Amanda.
Thanks, Kevin. So before we move into the question and answer component, I wanted to cover just a few things, kind of some next steps and where we're headed. So one thing I wanted to stress, and I think Kevin said this, but just to emphasize, seismic retrofit work will not be a contributing factor for other substantial alteration triggers. I know that's been a concern of some folks. Additionally, we've just spent the last few minutes reviewing the draft technical standard, and we will be publishing this to the SDCI website by the end of the month. And our plan is to develop a director's rule that will encourage these voluntary retrofits informed by this technical standard. And we're hoping to have that by the end of this year. Lastly, I know there's a lot of concerns about speeds of permit reviews, and we're actually currently hiring for a senior structural engineer that will be providing dedicated technical support to support URM permit reviews and providing answers rather, to questions during the retrofit process. So if you know anyone who's looking for work, make sure to send them that posting. And I also wanted to, you know, the big underlying question here is you've been talking everything voluntary. When is this going to be required? And right now we're thinking that the soonest we could have a mandatory ordinance in place would be summer 2025. And that's due to us really trying to be intentional, trying to identify funding resources, as well as, you know, resources for building owners and tenants to help them navigate the retrofit process. So this is, like I said at the beginning, this is a really complicated process. And so there's a lot of steps in place, a lot of steps that need to happen before we can get an ordinance in place. So again, this technical standard is set to be voluntary until we have that mandatory ordinance passed in mid-2025. So our last slide here is providing contact information for both myself and Kevin and Natalie Boholt, who is our technical codes manager. If you have questions on anything that you've seen today, you're welcome to email the three of us. We can provide answers. But I also wanted to open it up for question and answers. So if you are interested, you are welcome to raise your hand and I can call on you, or you can put a question into the chat. Right, we have one question, and that question that just came through, Kevin, you'll probably want to answer this, but it says, are there any provisions or guidance on how to address existing structures with inadequate structural separation from adjacent buildings? And how would the director's rule encourage voluntary retrofits?
Could you repeat that question one more time?
Yeah, sure. Are there any provisions or guidance on how to address existing structures with inadequate structural separation from adjacent buildings?
Great. Yeah, that's an excellent question and something that we certainly see a lot in this era as well. And this standard doesn't directly address those types of conditions. You know, like you said, there's issues with inadequate or non-existing seismic joints. There's issues with common party walls in these types of buildings. And it's not new to something that SDCI has dealt with. There's question, for example, of does a retrofitted building need to deal with the inertial mass of the building adjacent to it that maybe is not retrofitted? And those are all conditions that need to be addressed on kind of a case by case basis. And a good point to overall as it relates to that is if you will be doing a voluntary retrofit using this standard, we highly encourage a pre-submittal conference that we can talk about some of the specific unique conditions of your particular building that may not fit neatly into the box here. So that's very much anticipated, and we want to use that time to address those sorts of things.
Thanks, Kevin. The last half of that question was, how would the director's rule encourage voluntary retrofits? And I can answer that. And that is that we know that many building owners are currently delaying retrofit work because they're not sure what the future standard will be with the mandatory ordinance. And the director's rule, while voluntary, will be used to inform, or sorry, not the director's rule, the technical standard will be used to inform the development of that future mandatory ordinance. We have another question asking, will this PowerPoint be available or sent to all participants? It will be published to SDCI's website. We're doing the second version of this PowerPoint on, I think it's Monday of next week, and we'll be posting a recording as well as a present, as well as the slides. Another question, do you have any city funding for these retrofits? Currently, we do not have city funding. We are exploring options though. Some of these options include development of a transfer of development rights program for URM. So that would allow URM building owners to sell development rights for height of their structure. And they could use that funding in turn to fund the retrofit of their building. We're also exploring some different loan options, as well as pursuing some federal grants that would provide reimbursement for some engineering, design, and evaluation costs. So we are looking at multiple different funding sources. I'll mention tax credits as well. If you're interested in being a part of that conversation, feel free to send me an email asking to be part of our funding working group, and I would happily add you to that conversation. Let's see. There's another question asking if we can go back to the slide with the anticipated timeline. I can certainly do that. Go there. Let's see, another question. Can applications for review of retrofits via the alternate method be submitted after the technical standard is published? Kevin, do you want to answer that?
Sorry, could you repeat that one more time?
Can applications for review of retrofits via the alternate method be submitted after the technical standard is published?
Yes. Amanda, gets a little bit into kind of the nuance of how, from a policy standpoint, how we're going to be dealing with buildings that come in using the standard. But certainly, yes, the way it would currently work is it would fall under the voluntary seismic upgrade under Chapter 3 of the Seattle Existing Building Code. So it's voluntary work, just like any other voluntary seismic work that you would be able to do currently. Hopefully that answers the question. If not, maybe you can clarify.
Thanks, Kevin. The last question, again, this one's for you, Kevin. Is there any guide to calculate the use of epoxy on existing buildings?
Yeah, so for the alternate method, we essentially took some tables from Appendix A1 of the Seattle Existing Building Code, which has some information in there about capacities of different types of new building components, the anchors, for example, installed in an URM wall. So in those tables, there's also some footnotes that allow you to go use other methods, which the epoxy would fall under. And then there's proprietary epoxy out there that are documented with ICC reports, which is a kind of a standard that is used to confirm that they can be used in specific ways. And then also within those ICC reports, there's information about capacities that can be used if it's the epoxy anchors are installed per the document.
Thanks, Kevin. I don't see any more questions in the chat. You're welcome to come off of mute and ask questions that way. Otherwise, you can keep typing them into the chat. Oh, okay, the microphone is locked. I did not know that. I will go in and I'll fix that for the next meeting. Sorry, guys. I unlock it. Oh, I can request unmute. If you want to ask a question, you can raise your hand and I can unmute you. Okay, if there's no other questions, oh, there's another question. Let's see, will there be special inspection requirements for either the Bolts Plus or code-based approaches? Oh, you are muted, Kevin.
There we go. Yes, there are special inspection requirements just with as with any type of anchorage, whether mechanical anchor bolts or um, epoxy, there are special inspection requirements. We do waive some special inspection requirements if you're going to be through bolting the walls, so that's kind of the rosette type approach. There's some exceptions there. But the alternate method has information within it that talks about some of the QC requirements, which include special inspection. And then the code-based approach would just point you back to the regular building code. And that would be similar requirements.
Thanks, Kevin. We have another question asking, how do we keep up to date with updates? And I will say we are trying to keep our website relatively updated. There, you can sign up for our listserv, and that should email you when we post new things onto our website. We're also trying to post things in our building connections newsletter, and that you can subscribe to that as well. You can also join one of our working groups if you'd like. And if you're interested in that, you're welcome to email me. We are trying to post meeting notes and slides from those on our website as well. And I see it looks like I missed a question. Becca, is it anticipated that funding sources will be made available for sub-alt required retrofits? Some owners are avoiding changes that trigger sub-alt because of the cost. I would say that the funding isn't that we're pursuing wouldn't be specific to sub-alt or alternate method. It's just for retrofits in general, for seismic retrofit. So if you were pursuing funding, the transfer of development rights would work, as would the CPACER funding, which can also cover energy upgrade costs with low interest loans that stay on the property. So if you sell it, it goes to the next owner. And any grants that we look at would also not be specific to alternate method or substantial alteration. Let's see. Any other questions? Not seeing any. We can stick around for another few minutes should something come up. I know the meeting was scheduled till 4, but I don't want to waste anybody's time. So Kevin and I will stick around. I am going to stop recording, but if you have any questions, feel free.
Amanda, it might be worth noting real quick for everyone that's still here that the presentation on Monday will essentially be a repeat of this presentation.
Yeah, thanks for that reminder, Kevin. So yeah, if you attended today, you don't need to attend Monday unless you want to hear if there's different questions asked. Great.